Hi, 6th grade. Today we're going to be talking about deposition, compaction, and cementation, the last 3 steps in our formation of sedimentary rock. Now, at this point in your to-do list, you should have just finished the deposition activity, and you should already have notes on deposition, compaction, and cementation, but I wanted to kind of just talk about it a little bit more and clarify it. So if we take a look at the word deposition, one way to really help you remember what deposition means, we've been talking about using word clues. You really want to think about the word deposit. So when you think of deposit, a lot of people think of their checking account. So this is really wishful thinking, but I'm going to say I'm going to go drop $5,000 into my checking account. The whole process of dropping, that's what deposition is. So another way that you can think about it is deposition starts with D, and we're going to be dropping something. Now, when we're talking about sedimentary rocks, what is it that we're going to be dropping? It's going to be the sediment. Because in the step before this, in erosion, right now it's being carried away by wind or water. Eventually, what's going to happen is that wind or water is going to start decreasing in kinetic energy. And as that kinetic energy decreases, well, it's not going to be able to carry as much, and so those sediments are going to start to fall out. So let's just take a minute right now, and we're going to look at a video on YouTube so you can see what deposition would actually look like in a river. So we're going to model this with a stream table. So you can see right now, right here, these are the little rocks, and this is equating to a river, and then it's flowing into what would be the sea. So you can see as the river hits the larger body of water, the kinetic energy starts to decrease. And so then as it decreases, it can't carry all that sediment, and the sediment falls out, and it starts to pile up. Now, we're going to stop it right here, and we'll come back to this in a second when we move on to our next step. But that's as far as deposition. All it is the sediment dropping out of the wind or the water. Now, what's really interesting about this and kind of taking it to the next level is we want to think about, okay, as that water slows down, there's a decrease in that kinetic energy, what's going to fall out of it first? And if we look, the first thing that's going to fall out of it here are going to be the larger particles. So at first we're going to have rocks fall out, then the gravel will start to drop, but we still have sand, silt, and clay too, which is not shown here. But that sand falls out, and then eventually we're getting that silt. And silt is just really, really fine, like it's even smaller than sand, and clay is very, very fine too. So why this is important, the whole reason why we study rocks and we even care about rocks is because they are making up Earth. And rocks can really give us huge clues into what environments were like in the past. We want to study those past environments because they could give us clues to what our environment could eventually change back into. So when we look here at these 3 different types of sedimentary rock, if we have that large layer of bedrock, that tells us that at this time, this was the type of environment that was present. So with conglomerate, what this was telling us was that there was a lot of water that had a lot of energy to it because it could carry those pebbles. So we have very fast-moving rivers, something with a lot of energy to it. Whereas the sandstone, that's going to be forming where a river meets a body of water, where we're going to have a little bit more energy to it, but not a lot. So we might have kind of, quickly flowing rivers is where you see a lot of the sandstone, or the beaches, right where it's meeting a larger body of water. And then when we look at the shale is made out of silt and clay, and when we look, we can see, you can't even make out the particles making up that rock. So it's the texture would be no visible grain. That's forming out here. So where we're going to have really, really calm waters, shallow seas, or really, really deep, deep oceans, that's usually where we're going to see that shale forming. Now, what's interesting about deposition, we actually have a connection to social studies. You guys have studied Egypt, and I'm sure you learned about the Nile Delta. And right here, this is one of the largest deltas in the world. And it's formed because as that Nile River here and these other rivers come in and they hit the Mediterranean Sea, the energy of the water of the river starts to slow down. And as it slows down, we now know that that sediment is going to deposit out of the water. Well, that had a lot of very nutrient-rich sediment in it. So over years, as the sediment built up, then what ends up happening is we get this land that's forming that's very, very fertile. So this was really important for the whole development of the Nile region. Interestingly enough, they've actually dammed part of the river now, and so a lot of the nutrients that are coming down the river, they aren't as great as what they were in history. And so farmers now are starting to have to use fertilizer in order to add nutrients into the topsoil to still grow their plants. So this was just a really cool connection that I thought might help you remember deposition of that sediment falling out of the water. Now that we've talked about deposition and we saw, very naturally what's going to happen as the sediment starts to fall, we said it starts to build up. And so if we take a look here at this part of our video, as it's building, what you notice is the layers that are at the bottom, they start to become more compact and pressed together. So leads us to our next step, compaction. Once again, using your word clues, you can see the word compact in there. So the bottom layer is going to get pressed together, and they just keep compacting one another. Think of it like a trash compactor. I don't know if anybody's ever seen those before, but some houses will have them where it looks like a dishwasher, but you open it up, and what happens is you put in your trash, and then out comes a nice little square. So you probably have seen them in some sort of cartoon where they put it in and they come out as like a block. In real life, though, it's not a perfect little box. All it's doing is it's really pressing and compacting that trash together. So if you want to see a lot of businesses, they have commercial size compactors, which are huge. If you're a Star Wars fan, you can think about when they go down that chute when they're trying to save Princess Leia, and they get stuck down in this room that looks all metal, and there's that scary little alien thing that's down in the water and grabs Luke. Well, what they're also fighting on is the metal sides are coming together. So they actually went down a trash chute and they were in this large trash compactor. So this is what would have happened to, I think it was Luke and Leia and Han Solo if C-3PO and R2-D2 couldn't have overrode the system there. So you can see they have all that trash in there, and then the metal sides are starting to come together. And you can see just how all the trash is getting kind of pushed together in there. Kind of a slow process. We'll fast forward some. And then it kind of comes back out, and then they can dump more trash in there. So that's all that's happening with compaction as well. We have layer upon layer of rock coming down, and so it's pressing it all together. And then our last step then would be cementation. And again, use your word clues. You see the word cement. And so now those particles, what happens is they get cemented together. And this is probably the most confusing step because of how the cement actually forms. So if we take a look at what happens with compaction and cementation, then putting it together, this is kind of taking a look at all of the sediments that have gotten pressed down together. So they've been deposited. So you can see this right here is a sediment grain, and then there's water filling the pore spaces between the grain. And in this water, we have dissolved minerals. Then what happens is as they get compacted, we have less and less space in between here, and as that happens, that actually causes some of the minerals to start forming out of the water. And so then when you look here, we start to get the cementing minerals that have formed as that pore space has kind of been reduced. And so the minerals that we're using in order to cement the rocks together in sedimentary rock are usually calcite or quartz. It's forming a lot. So that is the last part of cementation. All you need to know is the sediments, they get glued together, and the minerals that are usually acting as that glue are quartz and calcite. So that's the overall of deposition, compaction, cementation. I hope you learned a little bit more and I was able to give you a little bit more detail. You are ready to move on to the next step in your to-do list.